Hello, my name is Tice Webster, and this will be my CSC 4575 final capstone report, which to kind of go over the agenda of this video, I'll be going over the main points of my report, just the details of that. Then I will move into a live mock demonstration of my code for week 3, just to show you guys how everything works for a live demonstration. Now, this project is essentially a secure hybrid cryptographic pipeline designed to achieve the CIA triad, which is confidentiality, integrity, and authenticity during data transmission between two different parties, aka Alice and Bob, which how this is done is through identity authentication. I used a long-term RSA 2048 keys with PSS padding to sign our exchanges. Then for key exchanges, I used an X25519 or elliptic curve to provide a shared secret with perfect forward secrecy. And just for the data itself, I utilize AES 256 and GCM mode, which provide both authenticated encryption and high performance bulk data transfer. Ultimately, combining all this is how I achieved the goals of this project, which if you move down, uh, my my project or my code, for instance, kind of follows a mutually authenticated handshake, which in actual implementation, first you have Alice who generates a ephemeral X25519 keys and signs them with her private key, which will be sent to Bob in transmission, where Bob will verify Alice's signature using her public RSA key. And if it is valid, Bob generates his own ephemeral key and signs them with his own private key, which is then transmitted back to Alice for verification, which Alice will then verify Bob's signature using his key. And after both signatures are verified, they will compute this shared secret, which the reason why I went through this design is because it will prevent man in the middle attacks where the attacker could substitute their own ephemeral key during the exchange, which I explained this in my report here. Now, kind of going further, so this is just all my network verification using Wireshark. The screenshots that this capstone project required, which was the proof of my key exchange, and also the proof of my confidentiality. Now, while building this, I had to follow strict defensive coding practices. For entropy, I used a OS your random parentheses 12 to ensure unique 12-byte nonces for every AES GCM operation. For side channel protection, I used that HMAC command for signature verification. This ensures constant time comparison, which prevents attackers from using time variances to guess valid signatures. And I also have some failsafe logic, which if a signature or tag is invalid, the system drops the connection immediately rather than trying to recover it. Now, after this, I have included also my weeks 1 through 3 AI research. Essentially, I just had to ask AI a question and then answer it using my own knowledge or other sources. And down here, also just my full code listing, but this is for week 3 to be specific. So now, if I move over here, I have both my terminals up. Let me get this code booted up so you can actually see it on Wireshark. So first, let's activate the server. You can see that Bob is listening. And then let me get Alex to send her key, which you can see right here. It goes through that little handshake process, and back here you can see the actual Wireshark catching all these packets being sent. But yeah, so this is my project. Thank you so much for listening, and have a great day.